There's so much more fun to come. Dr. Jenkins here. This next unit is on energy balance. So if you think about it, in previous chapters, we have gone through all the macronutrients. We talked about the micronutrients. We talked about some ergogenic aids. And now I want to circle around and just talk about energy balance, because we've talked about energy in, which are the nutrients through food. And we've also talked about energy out. We talked about basal metabolic rate, calories that we expend through exercise, and calories we expend through digesting food. So now we're going to put it all together and compare energy in to energy out. And of course, what goes along with that is how to handle the desire to either lose weight or gain weight in healthy ways. All right. Okay, so here is our outline. Let's just jump right in. We've already talked about this, right? Energy into our body would be the calories we bring in through food. And then calories out means calories expended. And we know, if you think back to that pie chart that I had on the PowerPoint in the video, we expend calories through basal metabolism, through exercise, and through digestion. Well, the idea would obviously be to have this be balanced. So for example, this is not rocket science, but it's worth considering. If all of a sudden you increase your exercise level, right? If all of a sudden you start a new training program, or you're bumping up your intensity or duration of exercise, if you don't change the calories in, then this becomes imbalanced and will have a calorie deficiency. So you want to balance things out. If you are exercising more, then you need to bring in more food. I know it's very simple, but I think it's very worthwhile to take a 10,000-foot view on this. Now, of course, there are going to be circumstances, I didn't mean to drop my pen on there. Of course, there's going to be circumstances where you may purposely want to have an imbalance. If you're trying to lose weight in a healthy way, well, you're probably going to slightly reduce your calorie intake and maybe slightly increase your energy expenditure. But we never want to have it be too far out of balance, because then we may either see excessive weight gain, fat, or we may see excessive energy depletion. All right, so I know that there's a lot that goes into this, and there are some science tidbits that are worthwhile. But like I said just a minute ago, I really believe it's worthwhile to start from the simplistic view, because a lot of people get into those specifics without even thinking about the 10,000-foot view, okay? Trying to consider an overall balance of calories in and calories out. Right. So we want the balance. I've already said this, but sometimes I like repetition, because then we see how important it is. And by the way, from day to day, it's not going to be exactly balanced. Who on earth, let's say that MyFitnessPal tells me I need to bring in 2,200 calories. Who on earth is able to every day hit the exact amount? That's not realistic. So some days you might be a little bit lower on one side than the other. So this morning I went for a pretty intense bike ride, so I probably burned more calories, and maybe I burned, 2,500 calories. So from day to day, you're going to see minor shifts. But the way to look at this is over the course of several days, a week, several weeks, are you more or less evening out? If I have a couple days where I expend more than I bring in, well, then maybe on my recovery days, I've got to reverse the trend. I've got to make up for that, I've got to bring in more calories than I expend. But over the course of weeks and months, it more or less should be similar, not the exact same. And if you want to tip the scales in one direction or another, then we can talk about doing that in a reasonable, thoughtful, healthy way. All right, this is all the review. This chapter, I think, tends to be a lot of common sense, but I think it's really worthwhile to go through, to put it all together, okay? So we talked about energy that's what I've been doing in red, and of course that's going to be through food and drink. And then energy that we expend, we talked about that pie chart, is through these three things. Don't forget that the majority of our energy expended in calories is simply to keep our organs going through basal metabolism. The most varied, of course, let me get a different color. The most varied, or what we have the most control over, is physical activity. So this is probably going to change much more from day to day, whereas the basal metabolism and this is food digestion, they're probably going to stay relatively the same. All right. I do get on one of my little soapboxes here, but it's no surprise to us that as a country here in the United States, people are getting more and more unhealthy. And a lot of that has to do with obesity. So I'm not going to ask you about these statistics specifically, at least most of them, but I just want to point out that it's a problem, and we know that. And, there's something, so I think many of you know, I have my PhD in exercise physiology, and when people hear that, they think, oh, like, you help athletes on the treadmill trying to maximize their VO2 max, or you work for a pro sports team, or you work at a gym. And those are, of course, places that we could work, right? But I also want to point out to you a new trend, and that is not just for athletes, but something, and if you look at the American College of Sports Medicine, ACSM, we're doing more and more research to show that exercise can be used as medicine. So if you talk about people with chronic kidney disease or people with heart disease, now we're putting exercise physiologists in rehab facilities, in hospitals, because there's a way to use exercise, of course, at an appropriate level. We're not going to have someone with kidney failure running a 5K just to start off. Something as simple as walking, lifting some very light, basic weights. Along with a reasonable diet, exercise helps everything. It helps kidneys work better. It helps to lower blood pressure over the long term. It helps people have a stronger heart. So when this course about sports nutrition, it's not just about sports. These are things that can improve everybody's life. All right. You can see more statistics about obesity. This is from the CDC, the Centers for Disease Control. I'm not going to ask you these stats, but you can see this is based on body mass index, which is talked about in our body composition chapter, which is the same unit. That's just basically a height and weight chart. You can see how obesity has increased over the last couple decades, okay? I went to look up the most recent CDC statistics, and instead of using BMI, now they use self-reporting. So it's no surprise that people report less obesity than there actually is. I'm not going to ask you about these. I'm just pointing out that we have a problem. And a lot of it's just due to our lifestyle changes, right? People are less likely to work at a job where they're up and around, more likely to be sitting down. It's also true worldwide. I'm not going to ask you these statistics, but I feel like these are statistics that are good to point out. What I do want to point out, something that I could ask you about, the age group that we tend to see the biggest rises in obesity are children. Okay? And that's pretty scary. I think in the next slide, or I forget if it's on there or not, but studies have shown that a child that is overweight or obese has a 70% chance of being overweight or obese as an adult. So it really sets you up in a hole, and it's very difficult to change your lifestyle at that point. Okay, you can just simply, if I were to ask you a multiple choice question, all these things contribute to our weight except, you'd be able to identify these. I think it's no surprise. What contributes to our weight? Well, what we choose to eat. Hopefully not that. What contributes to our weight? Our energy output, our basal metabolism, which is largely genetically controlled, but also our amount of physical activity. Gender can make a difference. For example, men tend to have an easier time of losing weight at the onset than women. Age, as we get older, basal metabolic rate goes down, so we tend to retain more weight. Environment, think about your physical environment, but also your emotional, the family you grew up in, what the eating habits were like, and genetics. Environment where you work, that's why I have this picture down here, all these things. Ha ha ha. We are finding more and more a field called epigenetics. I'm not going to ask you this on a quiz or anything, but where, there's no doubt that obesity has some genetic link. How much of it is genetics or nature versus nurture or environment? That's a very much harder question to answer. But what we find is when overweight or obese people have a baby, and then that baby is obese and they get older and have a baby, it seems to be altering the genetics in that family, making them more genetically prone to being overweight or obese. So I think we'll learn more about that in coming years. Okay, this is just talking about obesity and genetics. And you can see some of the sources about how much of your weight is a result of your genetics. I am not going to ask you these percentages because they're really wide. So the truth is, we don't know how much of our obesity is through or because of genes. We know that it plays a role. So what we can say is that genes play a role. So it's involved in your likelihood or risk of being overweight or obese, but it is not your destiny. And I really like to look at it this way. I take the view from all the research that I've read that we are genetically predisposed to be at a certain risk for obesity within a range. So to give you an example, and I'm just making up numbers, if I look at my parents personally, my mom has a little extra weight on her. My dad, not so much. But let's just say I have a genetic range where whatever that DNA marker is, right? Here's my little DNA helix. It's a really bad drawing. So whatever DNA it is, or DNA together, multiple that work together to determine your genetic range of weight. It's like a range. So let's say that based on my genes from my mother and my father, maybe I have a genetic range where my body's more likely to probably be between 130 and like 180 pounds. And I think we can all agree with this. Some people, no matter what they eat, stay skinny, and that's to some extent due to genetics. I know that I can't do that. If I eat a lot of bad stuff, my weight's going to go up. But I can also tell you that, one summer years ago, I trained overly hard and I didn't eat enough nutrition. And I got down to about 130 pounds, and it just didn't look right on me. I don't know, I guess I kind of have broader shoulders and hate to say the phrase big bone, but maybe that's me. So there's just a sense of the genes make a contribution. And you are not destined to be a certain weight, because how you live your life plays a big role in it also. But if we can get in the idea that your genetics kind of predispose you to a certain range of weights, and then what you do in your lifestyle determines where you fit in that range. Okay? All right. I've already mentioned this, but I just do want to make it a point. If your parents are overweight or obese, you have a much larger chance of being obese. You can see these statistics: doubles if your parents are overweight, triples if they're obese. Like I told you, a pretty good number is about 70%. So if your parents are overweight and obese, you likely have a 70% chance of being obese yourself. And that's, of course, due to genetics, but also environment, because these cannot be extracted from each other. The nature and nurture, they both play a role. Okay, I wanted to equate this to sports in some way, and this is not going to be on the test or anything, but many years ago I read an article about this, and I pulled up the article. It's an old article from 2009. I did include the article link at the bottom, but I just wanted to make a point. When we think about sports, as we'll talk about later in this chapter, we know certain sports desire certain weights and body types. So if you are a gymnast, it certainly favors, and you can do the gymnastics better if you are shorter and if you are pretty lean, right? Versus, say, a soccer goalie. Soccer goalie, it's very beneficial to be tall, much like it is to be a basketball player. This article here talks about football players, and more specifically, it talks about linemen. It used to be 30 years ago that the lineman would be 250 pounds. Now, let's look at the NFL, and now it's backtracking, not only the NFL, but if you want to get a Division I scholarship to a Division I football school, and you're a lineman, you better be approaching or at or above that 300-pound mark. And this article talks about that, the pressure for these young men who are in high school still to gain weight to get the scholarship. And this article talks about how difficult it was for these people after having graduated from college and entering the workforce, not in the NFL, because most people don't make the NFL, how difficult it was for them to lose that weight. So I think that's a really interesting thing. Okay. I talked about my belief, and it's based on research. We certainly don't have a clear answer. So from my research and my reading, I believe that our genetics contribute to a certain range of predetermined weight that we're likely to be at. It doesn't mean that you could never be above or below, but a predetermined range that you're likely to be at. There's something else called the set point theory. I'm not going to ask you about this. This kind of goes along with a range idea, but it's a little bit more specific. In the set point theory, it states that genetics play a bigger role, and that you kind of have a set point. And no matter what you do, your body is going to keep you at that certain set point. All right. You don't have to know these either. I already mentioned this in terms of epigenetics, how over generations we seem to be altering our genes. And one example of that is altering genes to make offspring more likely to be overweight or obese. There have been over 300 genes linked to body weight regulation. So there's a lot that we still have to learn about how they interact with each other and how this interacts with our environment. But I'm just pointing it out. Okay. So now that we know energy balance is calories in versus calories out, what are the things that regulate this in our body? This is a science course after all. And It should be no different, just like we've talked about in every other chapter, pretty much, what two body systems are responsible for controlling and overseeing our body. You got it. Nervous system, endocrine system. So it's no different when we talk about energy balance regulation. We rely on neurotransmitters and nerve impulses, and we rely on hormones. You do not have to know this particular neurotransmitter. I just wanted to give you an example. But I would like you to review that we rely on the nervous system and the endocrine system. Here are two examples of hormones that play a role in appetite. You do not have to know these either. What I do want to point out, what I would like you to know is in terms of the nervous system, our good old friend, the hypothalamus, this is our what's called satiety center. Satiety is a fancy word for hunger. So in that area of our brain, the hypothalamus, this is where our nervous system oversees our feelings of hunger or satiety. And then also working with the hypothalamus and nerve impulses would be a lot of hormones that travel all around the body. There are certain proteins as well, but you do not have to know this. Okay. Your book gets a little bit more detailed into this, but there's so many things, and that's what makes it difficult. First of all, we're getting feedback from our organs about what our GI tract needs. For example, there are sensors, there are stretch receptors in your stomach wall. And when your stomach shrinks because it doesn't have enough in it, then those stretch receptors sense, oh my God, there's less stretch, stomach is small, and they will send a nerve impulse to the brain, to the hypothalamus, which is probably right about down here. And they'll send a nerve impulse to the hypothalamus to tell you you're hungry. There will also be a release of a hormone called ghrelin to tell your hypothalamus that you're hungry. But it's not just that. Our hunger is influenced by psychological and social things. I mean, if you go to any kind of party and celebration, there's usually going to be food there. And if there's a cupcake sitting over there, and I'm kind of like, oh, there's a cupcake, I'm not really hungry, but it looks good, I'm probably going to want to eat it. Or maybe you go visit someone, and in a lot of cultures, it's rude if you don't accept people's food and don't try it. Or emotions. You're stressed out, you're sad, you're happy. A lot of people turn to food, right? We're also learning that our adipose cells, and if you want to get really fancy, adipocytes. So our fat tissue is adipose tissue, and it's made up of fat cells. So each one of these is a fat cell or an adipocyte, right? What we're learning, and this is newer stuff, folks, what we're learning is that these adipocytes release chemicals that act like hormones. And this leads to what you may have heard of, but perhaps not. It leads to what's called a metabolic syndrome, where if you're overeating, for example, if you're overeating, then your body is going to reset itself. So, for example, this hypothalamus, it is responsive to a lot of things. I've already mentioned it's responsive to feedback from the stomach and the liver. It's responsive to emotions, and it can reset itself. Okay? So if it used to be that X amount of food made your hypothalamus feel like your body was full, well, if you keep overeating, your stomach gets used to stretching more. Your hypothalamus gets so used to you eating more that it resets. Now, X food no longer makes you feel full. Now we need X plus Y food. And we think we're learning that this leads to a whole chemical cascade of reactions, particularly the adipocytes releasing these chemicals that act like hormones that make you feel even hungrier. And then these hormones from the adipocytes can also go to your blood vessels, to them to be clogged, to atherosclerosis. So there's a whole sort of craziness that's going on. I'm not going to ask you necessarily the specifics about these hormones, but I would like you to take home from this that there's many things that impact our hypothalamus and our appetite control. It's not just feedback from our body, it's emotions. And that, over time, these things can cause the hypothalamus to, quote unquote, reset itself. Okay? And that these fat cells are starting to act in ways that we didn't know that they act before. And most likely this is a negative thing. Whew, it's hard here because I want to talk about so much, but I'm trying to curtail so I don't get off too much. I mean, certain professors, come on, face it, certain professors talk way too much about other stuff. Hopefully I've been on point for the most part. All right. I've already said this, but social and environmental factors can also impact us, and they can even overcome our normal physiology. So if I go back here, the messages coming from here, from the social situation, from stress, can easily overpower the actual physiological data coming into your brain of whether or not you really are hungry. I mean, think if you work at an office, it probably happens every week that it's someone's birthday or there's some celebration. So there's cake in the break room and there's this. And if it's there and you're kind of bored or trying to pass the day, you're certainly going to be more likely to want to eat it. All right. Let's talk about energy imbalance. Well, actually, you know what I'm going to do? I'm going to pause the video. This is a longer topic. So we'll end this first part of the video and then we'll come back for part 2. Thanks, everyone.